I know you failed at it today. Okay.
Don't worry, guys.
We're gonna go check if you're coming in.
And they were talking crap. I'm understanding.
We actually weren't. We made-
No, actually, they were betting how fast you'd be able to run to here from the car lot.
Haters gonna hate, you know?
No, they gave you credit for being fast.
When you're on top, the haters just hate.
Okay.
Hey, where are you? On top. I'm on top.
So if everything goes well, we actually should be done with all of the information from the first half tomorrow. I mean, if it doesn't go well, then that's fine. I mean, that's kind of what Thursday's for. So I had it planned for us to go all the way through Thursday if needed. But so far, we've been able to get through everything fast enough. Turn this. We've been able to get through everything fast enough where I think we'll be done tomorrow. And if that's the case, I have an outline, but it's not like our normal outlines for this test. I'm possibly going to try to look for like not an activity. I mean, I'll call it a review. I forget their names. They have a specific name for these exercises. Circuits? I think they're called circuits. Essentially what they are is it's like 2 pages of boxes. And you start with box 1, do the problem, and then the answer to box 1 would lead you to whichever the other box is. So somewhere on the 2 pages. And then you would go to that box, do that problem, that answer would lead you to somewhere else along the boxes. And they're sort of self-grading because if you do everything correct, your last answer should be the first box. And so they're kind of nice because you guys essentially know if you do them right or not. Last year, the AP, have any of you guys watched any of the videos in AP Classroom?
No, sir.
Okay. I mean, like, I haven't signed it, I was just. So the people that do the AP Classroom videos were essentially the people that did like the live YouTube sessions last year, or recorded and live, whatever. And they were trying to cram everybody to get ready for the AP tests. And they do a really, really good job of explaining things. They're very thorough and detailed, but it's partially just sometimes leads down to time. But they generally created a circuit for every unit. So I'm hoping that unit 8 might have 2 circuits or something like that. So I'm going to try to look for that so that we could possibly use a circuit to get ready for the test. It might be something I might be able to make up myself, but we'll see. I'm not sure. I've never tried to take the time to make one myself. Something tells me they're not super good. Okay, but today's topic is one that we have sort of done before. We've started it in the past. I don't have a, there we go. Okay. So this is essentially what we have done so far this year. This was when we first learned definite integrals. So we talked about definite integrals representing the area under the curve, right? The curve in the x-axis. So this is something that we have done. I just don't know how well you remember it. On a scale of 0 to 5, how well do you remember this topic? Oh, it's all over the place. Okay, I will basically just teach it as if you haven't seen it. So this one says the shaded region that we are referring to is bounded by f of x equals, what was it? 2 over x equals 1, x equals e squared, and y equals 0, which sometimes they'll call the x-axis, to be referred to as whatever. So those 4 lines create this shape. Now, this particular shape could also be thought of as the area underneath the curve or between the curve and the x-axis. And when we first started definite integrals, that's kind of one way that you were presented what a definite integral is. So if I do the definite integral from 1 to e squared of a function, graphically, these two things represent each other. So as a graph, that's what it would look like. As an equation, that's what it would look. And then this is definitely something we know how to do and how to calculate. So we could integrate 2 over x, not even worrying about those bounds. The 2 on the top could be considered a multiplier in the front. So the integral of 1 over x would be natural log of absolute value of x. Now the absolute value isn't going to be needed because these are all positive. But nonetheless, we just put it on it first. And then usually you put a bar at the end to represent the numbers you're plugging in. And then I plug in the top number first. Subtract the bottom number plugged in. So ln is log base e. And in your mind, you're basically saying e to what power is e squared. So ln of e squared is 2. ln of 1 is you thinking in your head e to what power is 1. So that's why it's 0. So that exact area would be 4. Hopefully you remember some of this as we go through. The big point, though, is that the definite integral represents the area between the curve and the x-axis, because that's the fact we're going to use today to do all of it. One thing I forgot to mention, the actual title says finding the area between curves expressed as functions of x. So these are functions expressed as x. Because you're using the x variable, essentially it means we're doing everything vertically today. So tomorrow we're going to be doing the exact same topic, just horizontal. So if today goes well, tomorrow's usually goes really fast. That's why I think we'll be fine getting everything done today, tomorrow. But it all depends on how today goes. How are we on that? Does somebody want me to go over anything I wrote up there that you're not sure why? Or you wouldn't have been able to do on your own? I should probably open up the chat. Hey, look, there's a bunch of people that came late today. You guys got to start coming before 8:35 because I got to take attendance at the beginning of the hour. Okay, so 1, 2, 3, 4, 5. Oh, put that away. I don't. Really? Not the taste of it.
Other than raspberries.
I like kind of juice. Pineapple itself is great.
Is it that fibrous texture?
Nope.
It's like
I don't like watermelon.
it's like fruit celery.
It
It is like fruit celery, but it's so much better than celery. It's so it's not worse. Yeah, because it's
It's actually
like.
pretty true, yeah.
I don't like something, but I like.
All right. Move on. So this is gonna be similar as the last one. There's one thing different. Let's go with Josh. Who has his Chromebook open for some reason. Why do you guys leave Chromebooks open?
I just leave the sound
I'm
on.
not talking
They're
to
all
you.
the same.
I know, you.
You know.
There we go.
It's just a habit.
Let's not work on the other classes during this one. Or Khan Academy.
Oh, hand it over. Hand it over.
No, it's like we just had other classes, so I was working on this class.
Ah, I see, I see. Okay, so Josh, what's different about this one than the one we just did?
This one is correct.
This kind of looks like a parabola, but it's actually a trig. It's a sine function. Do you want me to go back to the other one? Okay. And if you can't figure it out, that's okay.
The other one is like what?
I mean, that part is 100% true. I guess I wasn't referring so much as the equations themselves. So the setup of the problem is different. Melissa. The setup of this problem is slightly different than the other one. If you were going to do this problem, you would have issues to start with. Perfect. So it doesn't give us bounds. It doesn't tell us where to integrate beginning and end. We can kind of tell the first one, like, just because it's obvious. But it doesn't tell us where to stop integrating. So this is also review, but I guess I wanted to show you the different styles. So you're not always going to be given the same information. Sometimes you have to figure some of the things out on your own. What is the same though, is going between a visual representation of area and an equation of area. That's always going to be the same setup. So it's the integral beginning to end of the area below the function in the x-axis. I keep saying below, but that's, if your function is below the x-axis, it's obviously not below. It's between that function and the x-axis. So 2 sine of x plus 1. And on this one, we essentially just have to figure out a and b. Now, a is obviously x equals 0 because it stops at the y-axis. So I can put in a 0. Alyssa, who are you going to call on for the next person? I thought that'd be a very safe choice. How do I figure out that top number? Ooh. Okay, do you want me to go get a drink so that you have time to like find it out for me? Not gonna make your nose. She would like some assistance if anybody knows.
What I said.
I 100% did not listen to what anybody did.
That's the.
That's a good thing about being a dad and a teacher, like, I have absolute control over what I want to block out or not.
Fair enough.
It's x equals 0, right? Is that what you
I didn't really use it at that time.
So 0 to 0?
said? No.
Oh,
No, like line equals,
Why?
like equals 0, that's the sign.
Go back.
Yeah, it's like finding the zeros. Yeah. Oh,
I think that's-
finding the x-intercept.
okay, how do we do that?
That's very.
Use the
It's like-
equation.
You're definitely not listening. You're definitely not
listening. Voice changed a lot, but it
So set f of x equals 0.
Okay, we can do that. So that location right there is the intersection of 2 separate lines. And it's completely correct to say the x-intercepts instead of equal to 0. The reason we do that is because this is the equation y equals 0. This blue one is the equation y equals 2 sine of x plus 1, which I don't think will fit there. Maybe. So we're finding the intersection of two separate lines. And if we want to set these two lines equal to each other, they both have a y, so we substitute 0 bits of the other y. So, I mean, whoa, what? Oh, that's a good. Yeah, there we go, school.
You're right. That's good.
So the reason I'm presenting it like this is because that's going to be a lot more useful to us throughout the rest of the lessons. Because most of the time, we're not going to find x-intercepts. We're going to have to find where two separate random ones cross each other. So you set their equations equal to each other. So 2 sine of x equals -1, sine of x equals -1/2. Yep, okay, and then I need to figure out where sine of x equals -1/2. And so 0 radians is right here. And I'm not sure where 2 pi is over here. I'm assuming it's somewhere like that. Maybe will that answer off the top of your head? Are you using your calculator to figure it out?
Yeah.
Still can't tell you the answer.
Why not? What did it tell you?
-0.52.
Oh. Yeah. Put that back in the link. Put that food up.
Hey.
I'm not allowed to bring in donuts and things this year. You're not allowed to. That is true, but.
Give each other a few times.
You didn't bring it in, you got it brought in for you.
I got it brought in for me too.
Why don't you mention that? I'm actually surprised they did do that because we're not supposed to have food in the rooms at all this year.
Really? When and it was the administration that was bringing the.
Yeah, that's why I said I didn't even think about it, but that's all right.
We need to stay cool. We did.
So here's how I solved this one. So do you guys remember the reference angles? Reference triangles? Okay. Looks like the bow tie or butterfly shape. So these are the 4 reference triangles that we use frequently to figure out angle sizes. So sine being -1/2, sine is the opposite side. So quadrant 1 and 2 are out because those are both positives. So sine being -1/2, this would be the first time we would run into it. -1/2. And there's only 2 triangles on the unit circle. The 30, 60, 90 triangle, 45, 45, 90. 30, 60, 90 triangle is 1 to 2 square to 3. Now the 1 is always across from the 30-degree angle. So I know this triangle that I'm looking for is 30 degrees past 180. 30 is pi 6. So I am going to go pi plus pi 6 to find this. Correct. I need to find that spot on the unit circle. So 7 pi, this was a lot of work just to find this answer. And that's what you'll find will make a lot of these problems go fairly slow. There's lots of work to be done just to fill out the very minor equations. So integrating 2 sine of x plus 1. You should know those. Listen, who are you going to call on the next person?
Eric?
So the one would just become x. And the sign would be negative cosine.
Good.
So -2 cosine of x plus f.
From 0 to 7,000.
Okay, here we go.
To save a little bit of time, I think we'll not finish this one. Because at this point, it's just you plugging in the numbers, getting the answer. The nice thing about me drawing this triangle, by the way, is you're going to keep that same angle and find answers from it. So you could use your scratch work to find out cosine of 7 pi 6. Okay. We're a third of the way into the deck. Half already. It's actually about right. Definitely the good and the bad about these hour and a half classes. Do you guys want me to leave this up? Yes, I'll wait. I suppose we better do this one. I'll just show you how to find the answer, but we won't actually find it. So this is a common free response question on the AP test. And because of that, it's kind of put into this section in content. So it's the same types of questions we've been doing, but the difference being you're asked to find the bound instead of like the area. So you're told all the other information this time, and you're supposed to find where that would stop. So that's why it's a frequent AP question, because they like to take the traditional normal problems you get, but change them around to see if you actually understand them. Who's our next person?
Hey,
Not that this is like, that's it.
No, yeah, it's fine.
Okay, okay. What should I do? Tell me what you like. How's that? Is that easier?
Yeah.
Okay.
So, well, I think I would just start by like writing what I'm trying to figure out. So I would write the integral from 0 to k
Good.
of 1 over x squared plus 1 dx. And then
What's that equal?
that would equal 5 over 3, yeah, because that's the area.
Yep, the integral is the area. This time we're actually told the area, so we're
Yeah.
equal to that.
So then when I want to actually integrate 1 over x squared plus 1.
Yep.
So that would become,
Yeah, I know, that's why I put this one.
you might need to give me a second.
I definitely.
Okay,
And I was gonna have everybody else try to figure it out too. These are the ones that are horrible. Because they seem like you should do it one method, but you absolutely don't. What I will tell you, it's not power rule, it's not natural law. But yet, these are considered acceptable to give you on the AP test, which is why I don't like them, and most of you will probably hate them too.
is it U substitution?
Nope.
Okay. No.
You guys want to try to look it up somewhere?
Yeah.
Use your brains and try to figure it out. And by saying that, I'm not trying to say in your head. You guys all have access to Chromebooks, computers, phones. I mean, this is what you have to do when you're stuck at an actual job, you try to figure it out. So look up things.
KT tape,
What's that?
it's for,
For,
no, I'm just having a hard pain because I play softball and I throw a lot.
that's like the same stuff they use in lakes for track.
I have KT tape on my back too. I had to go to the
What does
class.
KT stand
It's
I
just
think
brand,
it's
I
like
think.
kinesthetic tape,
Oh,
for?
which I don't know, well, yeah, but if you, they shorten it to KT and then you just say KT tape. Just K tape doesn't quite have the same ring.
Isn't kinesthetic, isn't that KT?
That, it also might just be that, kinesthetic. It's-
What'd you get? What did you Google?
I would Google integral calculator with steps.
No. You could have just Googled integral 1 over x squared plus 1.
But I got the steps with it.
Oh, okay. I mean, if you found the answer, that's fine.
I'm pulling it up.
But
Wait a minute, what? That's the last place I was going. That's not what I looked for.
So, arctan of what?
With X.
Good.
Plus
No, not a plus C because they have numbers.
That's what.
Let's just bring my phone.
It did.
So the arc functions are by far the worst ones to get the answers for because they absolutely do not appear like they are trig ones. So 1 over x squared plus 1 is arctan. I'm trying to remember arc sine, arc cosine, they're very close. They're 1 over square root of 1 minus x squared and 1 plus x squared, I think. So I gave you guys a formula sheet throughout the year. I don't know if you know if you still have it. I can certainly put it back on the Schoology page. That would be good. Okay. Otherwise, I'm hoping you guys start to understand, like, if I'm at home and I forget something, I just look it up. I don't like go to Schoology to download the formula. Like, you guys can just type in calc formulas and there's like a billion formula pages for you. You have access to way more than I do. So use it. All right, so let's go from here. I can't remember who.
Me.
Call the next person that is not fit.
You caught me.
Because you guys pick the same people all the time. Everybody basically has panic mode where it's time to call somebody else.
Finn,
I knew exactly.
And then they
what I was
immediately call
doing.
the person next to them.
what about Finn again?
Finn, okay, that's my full name.
All right.
Yeah.
Then I'm gonna need to phone a friend because I have no idea what it is. I got you.
Whoa.
Yes.
You're in way more trouble if you don't even know what to do from here.
Oh, you just plug it in.
That's what I'm telling you.
It's when I say, it's when I
That's
say.
a little
just
loud.
have a call.
Okay, that's nice. Pretty tough to do during the actual tests.
Well,
Okay, so what do I do here?
plug it in.
Just call me. Just call me.
No,
Okay, so you put the arctangent right there. Right.
just tell me what to write. That's probably easiest. I mean, it's okay if you want to explain it too, but like,
Five.
sometimes it's just easier to tell me what to write because then you don't have to like
You arctangent 0.
backwards, but yes.
Okay.
And arctangent k minus,
Top one minus bottom one.
yes, minus arctangent 0. Equals pi over 3, sorry, now our answer.
Who likes our answer?
Still correct. Arctan of 0 is 0 because tangent of 0 radians has an answer of 0 as a ratio. Arctan gives you the ratio, wants to know the angle. So when we're done, this was kind of backwards. You generally don't ever have an arc function of solving here, and I'll show you that one in a second. So either way, this one is 0, so we can just kind of cancel it out. So generally, the point of an arc trig function is to find out the angle. But this one, we know the angle. We actually want to know the ratio. So what we should do is rearrange it into the correct usage. Like you can't use your calculator to solve, I mean, like it's backwards. It's backwards from the whole purpose of arc functions. So tangent of pi thirds is actually the answer we're looking for. If you need to, draw it. I need you guys to get out of the habit of looking at a unit circle. If you are a person that memorizes a unit circle, fine, but then you have to have it memorized. So I traditionally always just do this because I'm not good at just memorizing all things. So pi thirds, I know is a 60-degree angle. Now this is where I was talking about the ratios. So a 30, 60, 90, that's really bad. 30, 60, 90 triangle is 1 to 2 to square root of 3. The 1 is always across from 30, the 2 is always the hypotenuse, square root of 3 is always the third one.
Right.
So these are the only two I ever remember, and then that's just on the other side. So tangent would be square root of 3 over 1. I'm only taking a lot of time on this problem because it's very good chance you're gonna get a question like this on the AP test. Now, since yours is gonna be all calculator, the main difference is that you, actually, no, I don't know how you're gonna be able to set that up on the calculator. I was gonna say you're gonna integrate on the calculator, can't. It would have to be set up as something to do by hand. So I would think the only helpful part about a calculator might be to like calculate something like that, or like
Yeah.
this. So your test is kind of new to me because we've never had one like that. And I generally know that this question is almost exclusively on the non-calculator portion of the test. So it's possible you'll have the same type of test, and they'll just tell you you can use calculator, but then make the problems that the calculator doesn't really help, like this maybe.
Someone who took the test told me, like, when they took it this last time, told me that on the, like, the, what are the questions at the end for your
Your
response?
response?
Yeah, that it literally says, like, you're probably not gonna finish these, so like, don't worry about it. It says that on the test, is that a thing that,
I don't remember the exact wording.
but does it say something about that?
I wouldn't know it.
Like, don't worry about finishing these, you probably won't.
I think it says you may not have enough time.
He said it was like, yeah, it basically says on the sheet that you won't finish them. And I was like, I don't like to have be confident.
The only reason they put that on there is because some people freak out thinking they should be able to have all 6 fair response questions done on time.
Yeah.
And it solely depends on how fast you can process things.
So that,
I realize the arc trig function threw you off, which is why I put it up here, because you're possibly gonna run into these. But maybe we should try to get moving. We might not finish today, that's okay.
so,
Yeah, I just teaching whatever we can. So now we're going to move into a new topic, which is the area between two curves. So the previous problems we just did was the area underneath one curve. I suppose I should write X equals 6.
I think I know what it is. Do you?
So these style questions are exactly like the ones we just went through in terms of there's two main styles. One style, like this one, you'll be told where to go from. The second style, they might have two different curved functions that would intersect each other and kind of create endpoints on their own. And then you'd have to find them. So we'll start by doing one of these first. Okay, 4 over x. I know that's going to be at the point 1, 4 and 4, 1. Well, I came up better website.
Oh, yeah, that would be different.
And then g of x equals 5 is a flat line, 5 pi. We are asked to find the area from 2 to 6. So the area of the region created by those two equations in 2 and 6 would look like this. Now, I'm starting off by working with graphs with you guys so that you kind of understand why we're doing some things. But traditionally, actually, art's given graphs. Tradition is just equation. Oh, all right.
Mr. McLeod, I'd like to call him.
Oh,
Thanks.
yo.
Breaking the system.
You guys, you're just totally wrong.
People are putting up walls and pushing them down.
It's like I wasn't ever explaining anything anyway. Who should I call?
Hey, we didn't give you a phone
Come
ring.
on now.
Oh, I'm still explaining. Melanie. Do you remember what the integral, the definite integral stood for? Like, let's say we do the definite integral of 5. What does it stand for?
The area between it and the axis.
Perfect. So if I integrated 5, it would give me this red section.
So you integrate, wouldn't you integrate both and then subtract the
Okay,
4x integral from the,
okay, good. If I integrate 4 over x, I get this. So our goal is going to be to take the red one, subtract the blue one, and that would leave us with the black crayon section. So you're always going to take the upper one minus the lower one. So in this case, the upper function is 5 minus the lower function. And the main reason we have to do upper minus lower is that so it's a positive answer.
How do you know which one's the upper function, which is the lower function?
I was actually going to get, I mean, from a graph, it's obvious. Well, I was going to get to that when we did one of the just equations. But you're right, that's usually the biggest issue, is how you know which one's which. The other thing that would possibly happen is if you accidentally have them backwards, you would get the correct answer, it would just be negative. So that'll be one way you can tell if you have them incorrect. Are you guys okay not finishing these by hand? How badly do you need to practice on this?
Wait, so you just solved that like normally, right?
Yeah,
All right.
so if you set it up. If you set up that definite integral, that would find the area between curves.
All right.
You pretty much just subtract the two curves that you have to find out how much area is between them. But yes, I mean, like, if we integrate this, plug in the numbers, that's it, we're done. It's not much more work than just finding with one equation. Okay, so here's one where we wouldn't be given endpoints. And they usually phrase it something like this: find the area of the region bounded by. No, 3x minus 2. And something else. Oh, x equals 0. So negative x squared. I'll make this semi-accurate just for your sake, but it doesn't matter if you do or don't. 2, 4. 3, 1. Oh, I know what I forgot to write over here. In the fourth quadrant. So that matters because it would be a different shape if we're looking at all quadrants. Well, that's an ugly parabola. But that's why I had my graph fully drawn here, is just because that was the point of the question. 3x minus 10 would start at negative 10 and go up through over 1. It's really hard to do this without a grid. And then x equals 0 is right here. Okay, so there's only, this is where some students get confused. There's only one enclosed section created by all three of those equations. When you're looking at this, though, it kind of looks like there's two separate enclosed areas. This section isn't enclosed by the three equations. So this section is enclosed by y equals 0, which isn't one of ours. So the only section that's enclosed by our three that we just drew would be this one. Okay. Alyssa, I think you were the one that answered before. Do you remember? I think you were the one that answered about the x-intercept before.
Oh, yeah.
Yeah, perfect. How do I find where they intersected it?
Was that point in for?
I don't know that point, so that's the problem.
Oh, right. That would be something you could do to it.
Good. So f of x and g of x is the same as y equals. So if I want to know where these two equations intersect, I'm going to set these two equal.
How do you know the point L becomes square root of
Yes. I mean, like, we're normally not going to pick. So, but yes. So we'll essentially just know if we did it right or not. So 3x minus 10 equal to negative x squared. Well, this is kind of nice. 5, 2. If we couldn't factor, then we'd have to do quadratic formula. So they do intersect twice, once way down there, and then once up here. So x equals 2 is the one we're looking for. We don't need the height of the point, we just need the x value. We can create some room here. So I'm gonna integrate from the first x value, which was kind of given, to the second x value, which we just found. Upper function, which is negative x squared, minus lower function. If it helps you, you can put the whole function in parentheses and then work that out afterwards. Because you're gonna start running into lots of negative signs. And you don't want something as dumb as a negative sign to give you a wrong answer. It always feels bad for me when I correct things and you do the calc part right, but then make mistakes on the algebra part. And it's not abnormal. I mean, like, that happens a lot, but. So as long as you do upper minus lower, your answer should be positive. You guys are welcome to type this into your calculator or computer, whatever, to check yourself. For me, it'd be a good thing for you to get really familiar with your calculators by the time you take the test. I have no idea what the answer is. I just made up the problem. So. Let's just have somebody figure it out. Is there any questions yet? No? Okay. So on a graph, you just, whichever one's on top, I guess. It is possible that like your shape is going to be so strange that sometimes hard to tell. So what I'll usually do is just put a single vertical line in there. And then that vertical line kind of helps you determine top. So that point is on that function, bottom, that point is on that function. I think every problem here on out is no pictures, and that's a different way of figuring out top and bottom. You ever get the message? I was just saying, it's really slow.
11.3. Just, yes.
Or, right. So because you're allowed calculator on every question, I'm going to assume that they're going to allow decimals in every answer. So as long as you make it up to 3 decimal places, they consider that okay. I mean, I haven't seen the official rules and things from them. I think they're probably trying to figure them out, just my guess. But I gotta imagine they would accept that on all the 3 responses. Okay. What is the area of the region between the graphs of 8x plus 6 and x minus x squared from x equals -6 to -1? So this one definitely tells us where we should integrate from because it has the x values. And then you'll start finding these go out faster once you get used to them because you know how to set them up. I'll give you guys time. Forgetting you're writing this down. I feel like I need to rush, but we have 25 minutes left. And I think the third portion of today is the same as second, but it's calculator active. And we're already doing that, so it's not really any different. All All right, Joe, you ready to shine?
Yeah.
How do you know which one's upper and lower, since we can't see them? What would you do? If you want a hint, nothing to do with calc. We're not going to use like slopes or anything like that. We just need to know which one's on top. Okay, good. What point would you plug in? You're absolutely correct. We could just plug in a point to find out which one's higher, but we kind of have to have specific numbers to try. You only need to try one, but we do need specific numbers to try. What would you plug in?
One.
Okay, how come? Nice, easy number?
Yeah.
Okay, good. Wouldn't work in this case. And I'm gonna guess somebody knows why.
Because it's between -1 and 6.
Yes. So the only stipulation we need to do is you need to pick a number that's what we're working with. Because it says from -6 to -1, we just need to pick any random number in there to try in both equations. And whichever one has the biggest answer is the one on the top. So, I mean, these aren't horrible numbers, but let's just go with -2, I guess. So that'd be -16 plus 6, which would give us -10. -2 minus +4 would be -6. So g of x is going to be our upper function. And then this is a great example of why the parentheses will help you out. Because you're going to end up subtracting that 6. And I know I've seen tons of students over the years leave the parentheses off and then they accidentally leave it as a +6. How are we on this one? Is this one okay for your setup wise? Okay. I wanted to get to the calculator ones because they are semi-different. And my guess is you may not know how to do this on the calculator. Oh, let me double check. Oh, it is tomorrow. Perfect. But I have to plan the calculator stuff for tomorrow. I was looking at all the different notes this week. Didn't even finish through that. No, I don't want to do that. Let's do that. Sorry, hopefully you didn't start writing all this. Which is too quick. It's pretty much the same words at first, isn't it?
I just don't have the equation.
Oh. Okay. So let's do these two. Let's go with Ben. Ben, what would you do first?
Would it be the plugging in to figure out which one goes on top, or do you need the anchor point things first?
Yes. So I was absolutely going to say that trying to figure out which equation on top is okay. But then the problem with that is we don't actually know which x values we need to pick between. We don't know where they cross yet.
Well, you define where the intersect is.
Perfect. Set those two equations equal to each other. Figure out where they intersect. Now, I set these two equations up so that they will only cross twice because we've got just two parabolas. But you could get really weird ones that have multiple, like 3, 4, 5 intersections, and that's kind of a different story.
Okay, Ellie, what did you get? Or are you still working on it?
I got -5 and 3.
Okay, did you guys get -5 and 3 as well? Excellent. Okay, we'll go with that. Nice.
So -5 and 3. So I'm gonna have the integral from -5 to 3.
Elijah. How do we figure out upper and lower now?
You pick a point between -5 and 3, and then put it
Good. There is a super easy one.
in, 1, 0.
Well, yeah, 1 would work, but 0, yeah.
So let's go with 0. So f of 0 is -8. G 0 is 7. So then g is the upper function, f is the lower function. So I'm going to do why don't you guys see if you can find that answer? I don't know if anybody's already typed it in there. I don't know the answer. But I think it'd be good if you guys can kind of verify with each other if we got it right.
Yeah, I think I looked at that one.
So if you guys don't have your calculator with you, a good one to go to they do have an app, but it's like $6. The main difference is it gives you a keyboard with calc symbols, but you don't need that. So if you go to this site on your phone, it has a mobile website, so it just comes up like an app anyway. And you just write the words, integrate, and then you put a space, and you would take this. You do the squares like you would kind of an old school. Oops, there's so this is just if you don't have your calculator. So you would take kind of the old school power symbol. And then you would say, comma, X. So if you have a TI-83, this is almost identical as a TI-83. Because you have to tell what variable you're using. And then you could say from X equals -5 to X equals 3, or it generally will let you type it like that. It accepts multiple things. Obviously, this one would be horrible to type in on your phone. That's why the app is kind of nice sometimes, because the keyboard that pops up has all the variables and numbers and everything that's there. What's our get? Oh,
5.3 repeating.
85.3 repeating? Okay, bad sign, but okay.
I have the same thing.
Really?
As,
Oh. What does it say after error syntax?
Not 85.3, but I probably took the wrong, there's a lot of
So it usually will give an error code with that though. And that kind of tells you.
Oh, I just didn't put the X by the D box.
How did you take that wrong though?
Oh, I know, I did right now.
Like, do you need parentheses or what?
No, just don't worry about
Okay.
what did you do then?
it. Don't worry.
Forgot one of the equations.
Don't worry.
Did everybody else get 85.3 repeated? Next. Okay, let's stop there. I think you're probably full for the day.
Oh, yeah.
Not on pineapple, not on pineapple. So we covered 3 different assignments from Khan Academy. I think I forgot to tell you to do quiz 1 yesterday. Did I include that? Okay, good. I did see a lot of people are super far behind on their assignments already. Don't let that go long
I'm
because
behind one day.
AP test time.
Same.
Yeah.
Like priority.
I'm not saying I just want to check up on everybody. Thursday, if you're really far behind, you could probably use Thursday to catch up. And then like maybe I could just have something for people who are already caught up to help them out, or, I'll just give it to everybody, but
What's Friday gonna be? So is it like on the Flex Friday or?
take the test. No, that's next week, isn't it?
Yeah.
Yeah, nothing. Friday is catch up day.
What about for the, or do we have anything tomorrow for the people who are taking AP tests?
What's tomorrow?
AP learning and AP micro. So I got that double.
So I would just watch the video. The topic is the same as what we did today, but everything is horizontal in terms of Y instead of in terms of X.
All right.
And then I'm gonna go over how to use the calculator, because there's gonna be some equations where you're not gonna be able to find intersection points by hand. So you have to use the calculator to find where the things at. So that's what I'm gonna go over. I think I already have one recorded. You're probably gonna do it after this fast anyway. But you're, because you'd be studying for the exam. Okay.
Suppose I better stop the recording.
Wait, which two AP tests do you have tomorrow?
AP learning